So our new season upon us, First Age was launched recently. Some kind of theme having to do with archaeology and or paleontology, I'm guessing. Specifically, first robotics competition is called Rebuilt, so I'm thinking it's more along the archaeological theme for the upcoming season. So this is one of our mentor sessions for the 2025 summer season, Coding and Robot Operation. And it's just a very light intro, as there's so much that can be done, maybe pointing the participants in various directions to get further information and support is one of the themes of this talk, as 1 hour to cover it all is a little bit ambitious. So with that in mind, I'm hoping we're making it very interactive. And if you have questions or comments or anything that comes up or comes to mind, please feel free during this very brief presentation to jump in. So we've had a few introductions already. Our teams represented this evening, 771, 7712, 8349, and so on, and 4039. And I'm sure we'll have some time to get a more interactive during the rest of our time here. So the first thing that comes to mind, if we're going to be using or coding on a first robotics robot, part of what we need to do is to install the software. And here on the screen, we have Visual Studio Code and WPI lib is what I call it. The actual creators of WPI lib call it WPI lib, but I just think lib sounds a little better. I don't know why. So I'll just take everyone through this little experience of setting up Visual Studio Code and a few things that came up for me that caused some issues. So I will go to now a web page and start up. Just going to Google search, I'm going to type in FRC control system. I've learned that over the years, if you type that into Google, it brings you to the page where it introduces for you all of the information needed to set up your robot. And just make it a little bit better for the web here. I'm just gonna, zoom it out. And this gives you not only the software, but also the hardware connections, but we're going to focus on the installing the software. And I'll take everyone through here just a little bit and point out a few things that have come up over the years with respect to the installation. And you'll see there's a detailed Python installation guide. Just going down through, scrolling through the installing the software, we have the offline installation preparation. And there are a few things that you probably want to install if you're going to get your full robot working. And I'm not focusing on these at the moment. Like, for example, the FRC game tools are necessary to have installed on your computer to try it out on the robot. So I think that's something to keep in mind since we don't have a robot available on a Zoom call. I'm just mentioning this, that this will have to be installed on your computer. The LabVIEW base installer is not usually required because it's kind of taken care of by the Java and C++ WPI lib installer. So this is where I went today. I actually went through this process today to update my computer. I was using last year's software. So here's the release. And if you go down here, you find your operating system in this list. And what it does, it installs. I'm not going to go through the install process. You basically say yes, yes, and it installs. Takes a little while. It's 2 gigs. So that's also something to keep in mind. It is a large download. Not to be done over someone else's Wi-Fi with low bandwidth. The result of this installation, I have quite a messy desktop here, but I will show you the new sort of icons that showed up. This is the previous one, the FRC code 2024, And here we have the newly installed one today. I don't know why there's an X on it, but it actually, oh, now I made it disappear, did I? Oh, that's no good. I think I'll be able to hopefully get it back here. Oh yeah, that's good. Control Z still works on my desktop. So here we have the shortcut to the VS Code. So one thing I really wanted to mention, and this comes up a lot, if you already have VS Code on your laptop, if you've been doing other development and you try to start using the FRC tools, it may not work. So I found out over the years you have to specifically install it through the first site, not try to download someone's code onto your existing VS Code. It comes installed with a bunch of libraries and things like this to really help develop software for your first robots. I'm just going to allow launching of this. Oh, it is allowing launching. It was working just before. Of course. Oh, no. Oh, that's it. Right click, allow launching. Where is it? Here we are. Okay, so there's the launch of the Visual Studio Code specifically for the first robotics competition. So they just wanted to emphasize that on several occasions I forgot that and used other installations of VS Code for other projects and forgot that you can't just import code and have it work. Even if you install the right libraries manually, it somehow just doesn't work. Getting it from first really does make a difference. So that's the first step here about getting going with the software, getting the right installation, and becoming familiar with VS Code. So there, you can take whole tutorials on how to use VS Code. I found it a little bit, yeah, well, not so exciting at first. I was accustomed to using very simple editors before that, and you really have to become accustomed to all the little selections and menus on VS Code to really make it work. So I'm going to sort of go through the process of setting up a brand new sort of code base and use a few examples here in the code to see what we can explore. So you may have to do some configuration before you actually do this. Sometimes you need to install some extra extensions, and I've done a lot of that in my VS Code lately. So you have to be aware some things may not work unless you've got some extensions. So I'm just starting from the very basics, just getting some basic code working. One of the magical shortcuts in VS Code that we can use to explore is Control Shift and P. And here we have our menu. And in here, we also can type in, oh my, now I'm having an issue because I'm thinking this may be, it's not letting me find WPI lib. And it was working just before the call here. Most interesting. Oh, well, that's most interesting that it's really not allowing me. Oh, there we go. No, it really is not. So in the whole process of doing what I just did right there, I may have started the wrong WPI lib. So I'm going to try starting it from here. Maybe that was the case. Oh, this is most interesting here. So I'm just going to go down into the directories and see if we can start that again. Yeah, for some reason, my WPI library has completely fallen out here. So maybe we'll go through the process very quickly to reinstall it. What should be happening, and what was happening just before our call, I was just doing the WPI library and it came up with some menus to start new software. So if you just allow me for a moment here, I'll sort of demonstrate it in my existing version of VS Code that is already working. And here's last year's, for example, Control Shift and P. Now you see what I was looking for, WPI library, create a new project. So let's just pretend this is 2025 version. It hasn't changed that much. And we go to a template and Java. You can use C++ if you like. There's a whole bunch of choices here, and I really recommend when you're just starting out to keep it as simple as possible. This timed robot is a very nice approach. We'll see it here. It all comes in one file. So to get you started, it's really great that way. And just going to go back to here, Java. I'm going to make a new folder, timed robot, and July 2025, and then create a folder to make my new code base in here. A project name, I'm going to call it timed robot, maybe timed robot 1, and I put my old team number in there just out of habit. There we are. And I'm putting enable desktop support because this allows us to do this simulation. And here we go, generate a project. And open the folder, and we should now see on the left-hand side here, if it's not showing, you go to these two documents and you see the whole file structure of the new project. And in here, the SRC folder and Java folders will hold all the code you really need to use. There are two Java files here, and we will take a look at both of them. This is just a sort of a starter file to get the robot base started. And we don't really modify this one here. The robot.java is where we will do all of the modification of our code. So there is a lot to learn. In here, this is the translation between items on your robot and code in the computer and logic for the robot to follow. And there are a few interesting things to think of in the introductory robot.java file. It operates very much like an Arduino in that there are certain parts of the code that only execute once and other parts of the code that operate continuously when the robot is operating. And we'll take a look down here. It all happens within this public class robot, which encapsulates all of the code to the very end of the file. So this is all within the class robot, extending timed robot, which is a class that's made for the FRC, and it's available through the WPI library. And you can see any method in here that says init will execute once. So this, when we initialize the robot, it sets up all of the options for the autonomous, for example. And that code comes with it. It already works. When the robot is operational, no matter in what mode, this code goes here. We don't have any code in there at the moment. And we can go through here and interpret each method like that. When we're setting up the robot for autonomous, this code happens once, just when it's going into autonomous mode. And then when it's working in autonomous mode, this happens. And we see this going down here. If we want to operate the robot in its teleoperated mode for the 2 minutes and 15 seconds, this is where we're going to have to put the code here in the init to get it set up and here to operate it. So the timed robot is very nice in that it all comes in one file, and you really only have to modify a small amount of code to get it working. We'll have to put a few commands in here to get the robot operation through teleop init and through teleop periodic to get it, say, responding to the controller and moving the motors around. The other part of the code you really have to pay attention to, we're going to have to import the motors, connect the motors up through what we call vendor dependencies. So if you have SparkMax motors, you have to add some additional code here from the SparkMax website. And if you have Rev motors, the same thing. And you include your motors here and you declare them inside the robot class. And that is really relatively straightforward to get a robot working within a file like this. If there are any questions or suggestions for the moment, please feel most welcome to, let me know. I'm not seeing the hands, for example, but if you have questions, please feel most welcome to ask. So I'm going to only show a few more things this evening because many of you will have different questions. So there's a new feature that has come up recently, and everyone knows that artificial intelligence is quite adept at sort of doing a lot of our coding. So I tried this the other day. I've been trying a few different artificial intelligence packages to write code. And this is a really interesting kind of game-changing feature of the internet now, because you can get a very, very detailed answer to a coding question from the artificial intelligence, and you can get a step-by-step development of the code, and it can critique your code, find the bugs in it, and tell you why it may not be working, for example. And with that in mind, we can answer a lot more questions for a lot more people using this sort of way. So I'm just going to show you my conversation, which came up the other day. I've only asked 2 questions to my artificial intelligence here. Please create a JavaScript to operate an FRC robot with 4 SparkMax controllers and 1 joystick. And that's a very common sort of rookie team requirement. And that usually takes about an hour or so using the old approach. But essentially, this took me the time it took to type in this sentence. Not only that, it explains how the whole code works. It's telling you what it's assuming. It's giving you the assumptions that it's in channels 1, 2, 3, and 4, which is a common way to define your 4 motors. And it's assuming port 0 for the joystick controller, and so on and so on. So it made a bunch of assumptions, and based on all of that, here's some very beautifully formatted code that is way better and way neater than I could have done on my own. Especially with my habits I developed when I was in elementary school. Coding neatness is not my forte. So as I was saying, in the previous sort of discussion, you have to import your motors, and there is the import of the CAN SparkMax motors. And those 2 imports are really helpful. Sometimes you forget these sort of things and you can look them up. Well, all of that is looked up with 1 single sentence now. Whereas before, when we may have had to go to Google to search each one of these to find out how to code this one sort of section at a time. It has imported the motors, and within our single robot timed robot class, which is very fortunate, it's the same timed robot, because did I tell it to do a timed robot? Oh, I didn't. It just gave me a timed robot. And that's really convenient because that's the same sort of robot code that I've sort of set up here. So we go back to our timed robot, and we have our 4 CAN Spark motors defined with left and right, front and rear. And we have 1 joystick defined and a differential drive defined. That was a new structure a few years ago that was confusing when they set it up because our code from the previous year stopped working. You have to watch for that. And you also may have to watch with artificial intelligence in case it was trained on some old code. This one appears to be quite fine as it is coming up with the more recent sort of coding sort of paradigms. And here we have the 4 motor channels defined and the controller channel defined. And Now we go into the initialization of the robot. We actually create an instance of each of the 4 motors. And that's what always caught me with Java. You have so many places that you have to define everything. In Python, we would have already been driving by about this line. But with Java, you have a lot more going on. So we define a specific instance or initiate instances of each of the 4 motors. And we create what we call a differential drive. And that's where we are linking the left motors and the right motors, or the front and the back together, however we want to do. And you really do have to get that carefully done because the motors you link together must be in the same gearbox. So here we have the left and right rear motors are following the left and right front motors, for example, assuming that they're in the same gearbox. And we inverted a few of the motors, assuming because they're on the opposite side of the robot that they have to be inverted to a -1 instead of 1, so that when we put the signal, they all go in the same direction. And we define a drive as a differential combination of the left and the right motors. And here's the final declaration we've built up over several lines of code that is now going to be implemented further down in our code. And that's in the teleop periodic section. The code here defines how we interpret the user's input through the axes of the joystick and find out how to move forward and turn. And we declare these constants forward and turn, and we modify them to avoid small joystick movements. That's something I didn't know before, and ChatGPT helped me. And there we have the drive command, which multiplies our input by some fractions to scale it down to make the control smoother. And that's the basic idea here. It took all of about 30 seconds or less to create all of this code through a single command entered into the artificial intelligence engine, in this case, Grok. And it would work fine probably with the other ones as well. ChatGPT I use interchangeably with Grok, and they're both doing similar things. So that's a really interesting thing. So if you have a question and you know how to give the right prompt, you can do a whole lot of code in a very short time. A single sentence becomes perhaps 100 lines of code. And that's what I really found really fascinating when I was preparing for this evening, that the availability of code through the artificial intelligence has only got much better in the last little while. When it first came out, it was not so complete, I remember. Now it's very, very easy to make very complete code, and it just seems to be so sharp. So I hope that that might be a tool that everyone might be able to use to answer some of your own questions. There is one thing to see this code here. It is another to actually put it into a robot and have it work. It depends on a few factors. You have to have your mechanical team having had the robot prepared and maintained with the correct motors and exactly what you're expecting from your code. So it's not just a single person job to get this code into a robot. And I think that's one of the challenges that we have when we are doing some online sessions like this. It's all fine to see this here. It's another experience to get the code into a robot and to make it work. And sometimes unforeseen challenges may arise. For example, a common thing that happens is one of your Spark Maxes may burn out. So the code may not look like it's working, but it actually is. And that happened to our rookie team here last year. One of their Spark Maxes was burnt and we had to replace it. Once we did, then the robot behaved as expected. So that's a few thoughts about sort of using artificial intelligence to enhance your understanding of and to make the development process for your code much more rapid. I'm just going to pause for a little here and go back to our sort of discussion here. We've talked about the installation and a few tips and tricks from this VS Code. One, even if you know the tips and tricks, seemingly, whatever happened that was working before our call is not working now. So I had to go back to last year's VS Code. Um, I showed a template, which was a timed robot. And there are also examples in the VS Code that you can try. I'm just going to take a moment just to give an example of one of these examples. Here we have Control Shift and P and create a new project. And we can go to in this case now, an example instead of a template. This is not complete code. And here's Java, for example. And in this case, I have a whole bunch of different code snippets that can be copied and pasted into the code. So for example, someone out in the community was asking about how to get vision working on a robot. So I'm going to do April tags vision, and I'm going to place the code in a new folder, which is in my Java folder here. Just make April tags the name of this file folder, and that should be it. And now the project name should be April tags, making this up as we go. And putting my team member in. And there we go. So let's see what comes up with the April tags. Again, you go to the source and Java, and that's going to contain two robot files. I'm going with with this example here, we only have one file as well. Whoa, and it looks like we had to import a lot of libraries to get all of this working. And there's going to be a whole bunch of example code here. So the vision thread starts. Wow, this is something to really explore and reflect on. There's a lot of detail in this example. So you may be able to paste this into your existing code, but it may take a little bit of setup to be able to use. Like, for example, if you're using a Limelight, you need to set up some network tables, and I'll show another example about that briefly. And you need to make sure that your camera is compatible with this code. And glancing down through this code, I haven't seen it before. I just sort of pulled it up as an example. We are using a Microsoft LifeCam. Just saw that in the code somewhere. Yeah, the HD3000, which was very common in kits of parts, at least when I was in Teams. I'm not sure if we're getting them these days, but the Microsoft LifeCam was very common. And so this code has been set up with that in mind. So you might be able to test this code on a robot, but again, it depends on the hardware you have and the availability of a team to work with it. And obviously, this code is a little more sort of advanced than the basic example that was shown just a few minutes ago. And it does require a fair amount of sort of understanding of the code dialect of Java that we're using here. So in theory, though, you can take this code and create a method within your code called April tag vision detector and make available the calculations required to find out what's going on the robotics field. And from the look of things here, it's finding shapes or April tags and then giving some kind of output that you can use to make decisions as to where the robot should go accordingly. So that's a little bit of a complicated example. You can try many of the examples here. Just go down to new project and we go to examples, Java, and you'll see lots of similar available examples for you to try out. Some of them are particular to other platforms like the XRP. Anything with an XRP in front of it is for the XRP robot. Anything with a Romy in front of it is from one of the older Romy robots. And some of them are only specific to types of drive that you may have. swerve drive, differential, or mechanism drive, for example. So not all of the examples are going to work for all of the code. This discussion here started very, very basic, but it also points to much more advanced stuff as you explore these examples and incorporate them in your code. And then I bring back ChatGPT again because I asked it to do something similar with vision. So I'm going to go back here and show my next question to ChatGPT, or in this case, Grok. Going down here, my second question I asked Grok was, please add code to the script that connects a limelight and returns the X and Y locations of any 36H11 April tags captured by the camera. So there's a reason I made this particular prompt for my code, in that the game manual specifies that it uses 36H11 April tags in this year's game. And then it gives a nice sort of explanation as to what we're talking about. And it's making some assumptions. It's modifying the existing code and assuming that we're connecting specifically a Limelight via network tables, which is a software package allowing devices to communicate over the network. And it's going to find the X and Y positions of the April tags. Maybe other teams did it another way. That's how we used to do it in my classroom, X and Y positions of, say, retroreflective tape that was showing up on the camera. And this is what it came up with. You'll see much of the code is similar to what we had. It's still defining the motors, but now it's got additional entries for the network tables. And going down here, it's instantiating a Limelight table and looking at the horizontal and vertical sort of position of a target, and also whether or not it is a valid target, meaning if we have detected, for example, an April tag. And I'm sure you could ask a similar question in your ChatGPT and then get some similar answers. It's very interesting. It gives some additional code snippets that allow you to move forward and use the data that has come through the Limelight. And then even some troubleshooting tips, everything all in one. So really an interesting sort of time we live in, where hundreds of lines of code can be written with a few sentences. And that does depend, of course, on understanding to a certain degree how the code works. To put it all together, you still need to have a certain understanding as to what's being done, because it doesn't always fit together so nicely with an actual robot. But there is a lot of progress being made in artificial intelligence at the moment. So I'm going to pause again here and maybe invite everyone to offer any comments or questions with respect to some of the things that we've talked about so far. Oh, and there is a good question from Travis. How permissible is the use of AI like this for writing code in competitions? This is something I didn't quite understand when I first joined FIRST. And my take on it is this is a very unique program. As long as what you're doing is in compliance with the rules in the rule book, then it's allowable. Up until this point, how you develop your code has not really been an issue. So you have to use certain code packages like Java or C++ within the framework of WPI lib. But aside from that, how you develop your code has not been regulated. So using AI to do this in a classroom may not sort of fit within previous sort of paradigms for learning coding. And there is a great danger, of course, with any new technology. There can be advantages and disadvantages. And for example, when we're talking about computer code, or say, for example, other inventions, a knife, for example, can hurt somebody or it could butter your bread. So using AI to code may turn your brain off and make you a very passive learner. But in the terms of how you take it, I think one of the responsibilities we all have collectively is how to use it to enhance the powers of the human mind and to maintain active learning with respect to whatever we're doing. So certainly AI can be used to ask and answer questions and to clarify things for us, and can be like a personal tutor. But it also could be used in a way where we get a very passive mind. An FRC robot is a very good example because it involves coding mixed with design and fabrication and assembly and all of kinds of other operations. It's not so simple like just writing a script on Python and that's it. So the code that you write still has to work with a physical object, and that allows us to be very actively involved still, and as far as I can gather. So that's a very interesting question that Travis has brought up here. How permissible is it to use AI for something? At the moment, it's perfectly and permissible. And in fact, we could even develop our own custom AI modules for vision detection and robot navigation. There's nothing stopping us from implementing a very sophisticated AI. We're only limited by the bandwidth of the computer processor on the RoboRio and the amount of memory and RAM available on that unit, for example. So that was a very good question. Yeah, very happy to take any other questions, comments, or thoughts from our group this evening.
Thank you for pointing out the example. I did not, years and years, I did not know their examples from the WPI lab.
Oh, that's really good to know.
It's like amazing. I'm just scanning through the list of like so many examples. Like this is so good.
And there's an interesting thing. If you're not so much into coding, I think that's partly why I introduced the AI. I can see with Mr. Filion, he's a computer teacher, and that's a whole other sort of thing. But for a mentor wanting to be able to support the students, the AI can help you to do a crash course on things and to get some quick answers. As a teacher, we really have to think about how do we do the teaching and learning process now. Bringing this into, for example, a grade 11 or grade 12 computer class, the development process for a FRC project, I may just, as we have Travis here, who is a teacher, and I could feel his teacher hat on through his question here. I'm just going to show another example and sort of recount how we connected ICS 3U and 4U to FRC in my previous classes when I was at London International Academy. So let me just share my screen again here. As we're talking about these examples, they are really great. I'm going to go to, instead of an example, another template. So we go here, and instead of an example, I'm going to select a template in Java. And this time I'm going to do a command robot. And again, make a base folder. I will select a folder in here. Okay, made a command robot folder. Oops. And name command robot. And the reason that I want to do a command robot, because I'm thinking about how can we link an entire class's work to, say, an FRC robot. So let's just take a look at the basic structure of a command robot now. You will see in the Java folder, there is a lot more going on. In the previous examples, we only had the two files, the main, which we basically don't touch. It just instantiates the robot file. The robot file was where all of the action was happening. There was nothing else. Now, the code has been distributed across several folders and several other files. And the reason I bring this up is this is ideal for a collaborative group work project. And collaborative group work really ties in to not only the ICS 3 and 4U curriculum, but also developing a first robot. When you first get started, a rookie team can just do a few lines of code to get that robot moving on the field. But to be competitive on the field, a lot more sophistication is required. So if you want to have a lot of people involved in the development, you can divide up the work through making commands and subsystems and modifying these various robot sort of systems here. So I'm just going to show a few of them, for example, and we can just sort of scan through a few of the robot container, the constants. We can define a whole bunch of things here that are public across the whole robot project. We still do some things in the main robot project, but most of the action is now happening in the subsystems and commands. We can think of the subsystems in relationship to the physical robot itself. So we can have an example subsystem that for, in some cases, one subsystem would just be the drive motors. Another subsystem would be the arm, and another would be the shooter. And that would be all the motors and sensors, anything that the robot manipulates through the code in a particular set of related components. So all the motors for drive and for steering, or all the motors for the arm, which has maybe a few sensors and motors required to work in sort of concert with each other to get something done. So we define all of the hardware in the subsystem, and then we can create a command to operate the subsystem. So there's our example subsystem. Our example command is going to call our example subsystem. And you see here, we import the subsystem's example subsystem, and then we work with an example subsystem that we're calling in our command. And that's how the code is organized. So we can have this set up with multiple commands, multiple subsystems, and even additional files when we get into vision processing and all the like. And that brings me back to our sort of discussion here. And we come down to version control. When you're working in a classroom setting, I found I used to use both GitHub and GitLab to keep track of everyone's code. And so you can have multiple students working on the same code base in different files, sometimes even on the same file, and they use this version control program to merge together their changes and maintain the integrity of the code. And you can have one branch of the code that is working, and then you start working on a new branch of the code without interfering with the working branch of the code. And so there's all kinds of things you can do to facilitate the collaboration of numerous people who don't even have to be in the same country, for that matter, to work on the code. During the pandemic, my programming team was in multiple countries, and it didn't really matter. So the use of these version control programs is also an entire sort of course on its own. You can get very deep into them, but it doesn't take that long to get started. And right now, VS Code, for example, if I go back to my VS Code here, there is this source control where we can initialize a version repository, publish it to GitHub, and keep it sort of updated on the internet so that anyone as part of the project can stay up to date with the code. But again, getting into that in a very short call is not really in the scope of what we should do. If you're into doing FRC in the classroom, that's a really great way to get all of your students collaborating together. So that was the next little part that I had hoped to discuss this evening. We went through several examples already, and I think that brings us to the discussion. I will have to leave this evening at 9 p.m. I have another meeting starting at 9, but I'm very happy to facilitate a few more comments, questions, suggestions, and all of that. And we will have some opportunity to expand on all of this next week in our in-person mentor sessions, as we will be meeting at Shinguakuzi School from Monday to Wednesday. These are set up in a kind of a self-organizing kind of way. If you have a robot that you would like to work on, you're welcome to bring it in. and several groups have done that so far in the most recent years. You can work on the coding, but you can also work on fabrication. We're going to have at least 2 individuals there to teach the fabrication of parts using the machine shop at Chinguakuzi School in Brampton. And yeah, we're really looking forward to that. We are having much more of a manufacturing flavor available this year, while still maintaining what we did in previous years. Some of the projects that were done in previous years, we had small groups of students create a module for the robot, like an intake or an arm. Some just got like a robot working. Others were getting pneumatic systems working, or coding the robot to do certain things, or taking apart and putting back together the control system on the robot. So we have lots of hands-on available things. Each of the years we've had the machines available, but we've only had an opportunity to peripherally work with them. Now we are bringing in particularly Monday and Tuesday individuals who are trained to develop parts and with machines such as bandsaws, drill presses, and maybe even some CNCs and whatever we have. So it's a kind of an interactive marketplace for learning that we've set up, where anyone with a particular interest might be able to find some other group members with similar interests and design and carry out the design of some part of a robot over a few days, whether that's with your robot or a few sample robots that we bring in. So yeah, that's what we're looking forward to on Monday, Tuesday, and Wednesday of next week in Brampton. And yeah, we still have a few more minutes left, and glad to take any particular suggestions or comments about future topics. I'm really intrigued about the Python topic, and it would be great to go from 0 to working robot in Python in a little session in a future time. And that's something we could also do next week.
That's awesome. Thank you.
Thank you so much.
Thank you, William. This was great. I
Thank
really
you.
appreciate the exercise using AI. It gives us at least a good starting point.
It kind of shocked me when I tried it. I was like thinking, well, maybe it'll help a little bit, but it was so shockingly clear when I did it this time that it's even, yeah, getting more and more surprising all the time. Thank you so much, Dwayne. Very nice to see you, and I hope all is well with Team 4617 as well. So with that, dear friends, hoping to see all of you in future mentor sessions on Tuesday evenings for the next few weeks. And in addition, next Monday, Tuesday, and Wednesday at Chinguakuzi in Brampton. So I'll stop our recording now. And very happy